Hello, everyone, and welcome to today's SANS webcast. Detect Everything, bring Google Scale NDR to your security operations. Sponsored by Google Cloud and Corelight. My name is Carol Auth of SANS. Today's featured speakers are Bernard Brantley, Chief Information Security Officer at Corelight, Dr. Anton Chuvakin, Head of Solution Strategy at Chronicle, and Edward Smith, Senior Product Marketing Manager at Corelight. Edward will be moderating today's webcast. If you're in the webcast, you have any questions for our presenters, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to turn the webcast over to our presenters.
Thanks, Carol. Hello, everybody, and good morning and good afternoon. Just a quick note on the agenda that we'll be covering today. So to start off, Anton is going to cover from a high level why network monitoring and network telemetry is important, and he'll also go over some common misconceptions. Then we'll do a bit of a deep dive into the world of cloud security and the role that network monitoring plays in cloud environments. And then Bernard's going to go into some specific use cases, taking a look at some examples for cloud infrastructure as a service environments and showcasing kind of the value of network monitoring. And then we'll wrap it up with a picture of what an NDR stack looks like along with a reference architecture. And with that, I will hand it off to our first presenter with Anton.
Perfect, thank you very much. And again, this will be very fun, even though I guess some of you may know some of these things, but I want to highlight and strike them for people who haven't really dealt with this in recent history. So when I was an analyst, a lot of people kind of asked me questions about the approaches to monitoring architectures, comparative value of doing network endpoint, buying different products. So the story kind of converges to a pretty complicated mesh of monitoring approaches in different environments. However, one of the approaches usually stands out as a well-known popular choice, namely monitoring on the network. That's what we're discussing today. However, over the years, I started to feel like we are sort of pivoting too much to the EDR, to the endpoint side, and the network is not getting the value and the recognition and in the usage, of course, as well, that it deserves. So I want to hit the points on the slide by explaining again for some and reminding others that network security monitoring and focusing on the network side when you do threat detection and response is quite critical today, and it still is critical in modern environments. In fact, as my first point indicates, some of the modern environments that didn't exist 10 years ago, of course, there's a lot of IoT, there's a lot of cloud, there's a lot of bring your own device of many kinds, makes it difficult for some of the competing approaches like, well, agents, like some other approaches on the endpoint. And so unmanaged and kind of lightly managed devices and their proliferation still gives a big boost to network side. And of course, some devices just cannot be instrumented with agents. And so that to me is a strong argument for network side. Now, what about broad coverage? When people want to detect something in their environment, they can say, okay, I'm going to detect where the attacker is, and the attacker is probably on the endpoint. However, to detect an attacker on a particular endpoint, you have to be observing on that very endpoint. Now, that's not very broad, that's actually very narrow and focused. What if you want breadth? What if you want to have one system, one sensor, or a small number of sensors that would highlight a lot of different systems of different types, both managed and unmanaged? And again, that's network side, that's network security monitoring we're discussing using NDR type tools. So broad coverage to me is a high value for many people, and it's been kind of forgotten a little bit. When I was an analyst, maybe in the mid-2010s, 2015, 16, I've met a lot of people who would always choose network over endpoint simply because they did not want to deal with agents. Now, that problem has tempered a little bit nowadays, but it still is a big value point. You don't need agents, you're invisible to attackers, you're difficult to tamper, you can cover many machines with the same set of sensors, a small set of sensors at that. So to me, these are still very real and they matter, and some of them matter more now than before. Now, to me, the out of band element is also critical. So it's kind of a derivative of point number 3 about being difficult to tamper, but you're also not disrupting anything. Nobody can blame you for kernel crashes, for machines being slow. And of course, I know that good EDR vendors don't really mess up your machines. Now, do they? On the network side, we know that it's impossible to interfere with anything because you are out of band, you are passive, you are low to no disruption. Now, there are caveats to that, but the strong argument remains that you're getting the value without ruining anybody's lunch, like say your IT support team. Now, it also provides communication context that endpoint sometimes lacks. Sure, you can sniff traffic departing and entering the endpoint. You can do all sorts of sneaky monitoring at the kernel level and look at drivers and look at programs that connect, but ultimately you don't know what truly went on the wire. In case of network, you have the clear contents, if unencrypted, or clear context for communication. To me, this is important. And while you can always come up with a half argument as to why endpoint is okay, I would say that here we give you a full answer. You're looking at traffic, you know who communicates with what, even though because of encryption, you don't always know what they talk about, which highlights both points number 5 and number 6. You do have an authoritative record of device communication. Telepathy isn't really real, at least not in IT. So you can't, if you're communicating, if a device in your environment communicates, it probably uses the network, like with a 99.99% of accuracy. So in light of this, you are observing the traffic and you know that the communication is going on. To me, this matters. It matters for people who want to have certainty in their detection, not just likelihood. Next slide, please. Now, as the points I mentioned remain to be true, there are a lot more people who sort of doubt them, forget them, or maybe they were born before they were first presented by people like Richard Batley and others many, many years ago. Now, today we have people who say, the world have changed. It's all encrypted now. This network stuff is useless because it's all going to be bit streams and stuff like that. First is, it's sort of getting to be true for certain protocols, and it's certainly getting to be true for internet traffic. But when I was an analyst, we looked pretty deep at how much of internal traffic, what we would call east-west, is encrypted. And the percentage varies dramatically by company, but there are many, many, many organizations when east-west is not encrypted. So you're observing a lot of that, and you're not suffering from encryption. Now, there are absolutely ways to both analyze encrypted data and occasionally safely, well, I'm using air quotes, safely break the encryption and observe what's going on. So to me, this is not really a doomsday for network security monitoring. This is a constraint, but ultimately we do get value from observing traffic, even though it's encrypted in many cases. Now, sometimes people buy an appliance from some kind of a AI vendor who claims to detect every possible threat, but all they do is they monitor egress, ingress. They monitor north-south. And it sounds like these companies never heard of like lateral movement, like attackers being inside and doing stuff. Like it sounds like it passed them by. Ultimately, if you're doing the monitoring, you do need to look at egress, ingress, and also lateral traffic. You're not just observing what leaves your environment, what comes in. So to me, this is interesting that I would expect this misconception to have died 2 decades ago, when people started thinking, wait a second, what about lateral? But apparently people believe that now sometimes. So you need to look at egress, ingress, and also at the lateral. Now, number 3 about network monitoring being an auxiliary control is kind of sort of true for many companies today. As my discussions with both vendors and clients and my analyst days indicate, enough companies would deploy some form of endpoint telemetry, and they would deploy some form of SIEM or log analysis, and then they would deploy network. Admittedly, the opposite also happens. People would deploy network sensors at a small number of choke points, and then they would gain more time to then instrument machines with endpoints, with these agents. Now, to me, 3 is in essence a half-truth. For many companies, it's an auxiliary control, but for some companies, NDR type technologies is a primary control, and then agents come later. Now, people who go way back, and I mean back to the 90s when Wireshark and TCP dump were invented, they sort of assume that you have to do pickup if you're doing network. If you're doing NDR, if you're doing NSM, you have to have pickups. And frankly, sometimes I feel like those people have never heard of Zeek and its predecessor Bro, of course, because hey, we have rich layer 7 metadata. Why do you need every YouTube video users watched. You can go to YouTube for that. You don't really need to record PCAPs for many, many types of traffic. So to me, I want to change this and say layer 7 metadata, it didn't happen. I don't think it's really about PCAPs anymore. Given encryption, given a lot of public internet traffic, given many other reasons, I don't really see a dramatic need to capture PCAP for many cases. And yes, I would certainly, I'm sure you can find examples where you have to have PCAP, and of course, you can have selective capture. But to me, full packet capture for all traffic is kind of gone. It is not a thing anymore, and nobody can do it, and nobody should do it, frankly. Now, what about price? Now, people who believe that it must be PCAP would tend to jump to number 5 immediately and say, hey, this is too expensive, we can't do it. And then they sort of like close the door on the NDR and NSM and say, we're going to do something else, as if agents are cheap. So to me, if you're doing PCAPs, it may in fact be too expensive to capture and retain. Again, in my analyst days, I've seen people who do pretty wide-ranging full packet capture, and they do go hard on that, and then they retain for 7 days. And I'm like, wait a second, are you going to always detect an attacker within 7 days? Look at the industry reports. I'm not saying 7 days. I'm seeing more like 200 days. Are you saving your packets for 200 days? And they're like, no, we're saving them for 7 days. Well, either you should detect much better, or you should use other approaches. Of course, I would keep packets if I can for some time, but then I keep network metadata for much longer. Now, Richard Steenan is now my friend, and I know him really well, and he is a really smart guy and a former analyst. He did declare IDS to be dead in 2003, and in many regards, this have come to haunt him, but NDR and the modern detection approaches are very much alive, and we do want to detect on the network. Soon we're going to celebrate 20 years of IDS is dead in 2023, I'm assuming, and by that time, I'm pretty sure we'll do a lot more NDR. So in that sense, Richard is kind of right, but also not right. Now, the final point is we're going to dedicate a bit more attention to, namely that cloud native architectures, all this modern microservices stuff and containers means you don't need network capture. You can do something else. You can do like magic observability stuff, or you do some in-app telemetry of another kind. Now, frankly, this is theoretically maybe can be true in theory, but in practice, people are dropping VMs in the cloud like there's no tomorrow. People are replicating some legacy architectures that they really shouldn't be doing, but they do. And for these approaches, to me, NDR remains a very strong answer, as you'd see in one of the blog posts that we link later. So let's drill down on the cloud side specifically, because we do see a lot of people adopting cloud computing. Of course, the big three. I'm wearing my Google Cloud T-shirt here. So the idea is that people who move to the cloud in a cloud native way occasionally look kind of with skepticism at NDR, and they say, hey, I think that NDR and frankly, even the agents as well are kind of more legacy approaches from the on-premise world. And they kind of criticize and say, hey, I have everything locked down, I have a mutable infrastructure, I encrypt everything, I have certificates everywhere, and provider gives me logs. So they bring up those arguments and they say, yeah, I don't really see the need for doing NDR. Now, frankly, these points, as I said, can be true in some environments, but also if every single point is true in your environment, because you're this absolute cloud native and a company that didn't exist 2 years ago, and you're all SaaS and IaaS, and you have nothing on-prem, you may be in the reduced need for NDR for sure, especially if you're all SaaS, but it is just not a typical case for both a modern enterprise and for a legacy enterprise adopting the cloud. So these points may be true, maybe partially true, but they're never all true at a single company, or maybe they're true at very few companies. So if you go to the next slide, you'd see that there are actually valuable points and valuable kind of like clusters of value that NDR delivers for most, except for the most extreme cases of cloud usage. Of course, network flow logs are shallow, cloud API logs are not exhaustive, they miss things, they may be just as voluminous, and you may not have tools to analyze them. Frankly, I was looking at some observability stuff lately at the in-app analytics for security purposes, and I'm seeing a lot of data, and I don't see a lot of security use cases. So even if you are given a whole bunch of API logs, you may not have a tool to actually give you insight. Now, for layer 7 metadata, you do. Zeek, Chronicle, other tools. So in essence, you know what to do with layer 7 metadata, but you may not know what to do with cloud API logs to detect threats. Now, eventually you'd learn, but as of today, there's still high value in that. And as companies who replicate some version of their on-premise infrastructure recognized, a lot of cloud native benefits accrue over time. They don't happen day one. So day one, they absolutely have to deploy some of the controls we're discussing. So to me, the arguments for using NDR in the cloud and not using NDR in the cloud today resolve in favor of using it for most organizations, except for maybe very few fringe cases. That's why cloud providers build things like packet mirroring in GCP and many other ways to capture traffic. Next slide, please.
Morning and afternoon, everyone. Thanks again, Anton. Great points as a lead in here. I 100% agree with the route to deployment in the cloud, that we have not yet reached a point that cloud native technologies are the de facto standard, that we are migrating what look to be on-prem workflows and architectures directly into the cloud. And for that reason, NDR is still extremely relevant. Even more so as we move into this more advanced and more mature understanding of how to use these services within the cloud and the blind spots that it may provide. But we'll dive into that in a few slides. So what we see here is a representation of the rich metadata that Zeek produces by analyzing network packets between layer 3 and layer 7. For those who are unaware, Zeek is an open source software formerly known as Bro. It was born out of UC Berkeley, in the same place that PCAP was born. In fact, Vern Paxson and Steve McCann both have ties to Corelight. Vern Paxson, our chief scientist, was the creator here. But to say that the historical approach to evaluating the network through things like PCAP with T-Shark and Wireshark and other, and this more summarized view of the network came out of the same place is just amazing to think about, that both have been around for essentially the same time period, and that we're in a place now where this is really gaining traction. So if we walk this slide from left to right, you can see that as a reflective example, the HTTP log. As Zeek analyzes these packets, it generates two things. One is a record of the connection, which is similar to flow logs as people understand them, with some more advanced metadata associated with it. And the second is a protocol-based output that gives full details of exactly what happened within that transaction. I think this is probably one of the most wonderful things about this overall approach, is that, one, it's policy agnostic, meaning that there is no way to perturb the data in a way that means it's not represented as a comprehensive view of what happened on the network. And that, two, with it being a summarized version of what happened in the network, it migrates the problem from how do I analyze a PCAP and what is the talent and skill sets required to go deep into PCAP analysis, and moves that into, we're now facing a data problem. How do I analyze the data and generate outcomes that are more specific to my needs or my mission? Or how do I generate outcomes that are more accessible to others within my organization? I think that it's a step up the ladder rather than a step down the ladder to say that now, with the talent that we have in our SOCs or in our business analyst departments, that analyzing data is a native and well understood tool to many organizations, versus PCAP analysis, which is a very specific thing. As a CISO, I tend to measure things with respect to capability and maturity, right? So if we take something like the CMMC, the Cyber Maturity Model certification, and look at something within that being incident response or SOC operations, and look at the maturity levels, one of the beauties here is that this data meets you wherever you're at, right? We can start at the very basics and say, am I able to analyze the network with respect to flow data? Yes, that's available in the con log. If I have nothing more than a connection or a connection string that I'm aware of and know how to analyze, I can go do that very simply in the con log. However, as I move up that maturity level and look at things like, hey, I'm managing my network operations, I'm managing my detections, or I'm looking at optimizing these things, and very well aware of the use cases and the operations of my network, and want to get very specific about, what are the URI strings, or what are the HTTP referrer fields, or who are the user agents that are being used. I can leverage this same exact data set and generate some extremely positive outcomes that, again, meet me exactly where I'm at from a maturity level within my SOC. So on top of this, things that are somewhat more Corelight specific is we release content, right? That you are not locked into only representing the data on the network in this way. There's two underlying mechanisms, one being the protocol parser. Within Zeek 4.0, we moved to the spicy protocol analyzer, meaning that we're no longer only constrained to the network for generation of log files that represent whatever's happening in context of the network. We can look at things like APIs or file transactions. And the second of which being the Zeek scripting engine, which is extremely extensible, allowing a skilled analyst or allowing content creators to go view the network, understand exactly what type of log output they want to summarize, code those things into the Zeek engine, and export those as an object for uptake within your SIEM or within your data analytics platform. Corelight, the companies, utilize these things to produce rich content for our customers in things like the C2 collection, or the Encrypted Traffic Insights collection, or the Core collection. We are able to generate and produce inferences in what's happening within your encrypted connections, or what's happening within C2 channels, or things like DNS tunnels or DNS logs. So what we've done is reached out to some of our amazing customers and asked exactly how they're using our tools within their cloud infrastructures. And we've had a couple that have replied back. So as we roll into the next slide, I'm going to go through a few of the use cases that we've gotten and kind of walk them to show the overall value of Zeek with cloud native deployments and in highlighting the gaps that we provide visibility into. So I'm sure everyone is familiar with what DGA is, but as a refresh, domain generation algorithms are randomized domains generated by a malware program that allows them to establish communications or register domains to evade sinkholing. This is a common practice for many malware creators and a path to evading what should be static-based detections or static-based prevention controls. At current, what we see is that there's a lot of content out there. There are cloud native alerting capabilities or cloud native detection capabilities that make the claim that they are able to detect domain generation algorithms. However, in the case that they are working off of some type of list or is signature based, those things are often not updated or have the potential to generate a high amount of false positives. If you're looking at the other side, where this is more machine learning oriented or behaviorally oriented, we run into the problem where alerts are not firing fast enough or sometimes may never fire. In the case of this customer, they were noticing that things that they identified as domain generated algorithms were either firing as alerts hours later, sometimes days later, or not at all. So with that being said, with the current cloud native offerings, when an alert does fire, there's minimal context and minimal ability to action these things. You typically only see something like the instance ID and the DNS name or the source destination IP, but the DNS query type or the response value is missing. It's one of those areas where, regardless of whether you become aware that there is some problem, the ability to decipher what that problem is and then go act and resolve that problem takes many cycles by the SOC and is inefficient. Lastly, like I mentioned, the amount of false positives is extremely high. People who leverage things like CDNs that use randomly generated domains to serve their many customers often show up as domain generated algorithms within many of our detection products. So we provide a solution there by just representing the DNS logs as they are, right? That within that DNS log, you can see on the right side of the slide, we express to the customers things like the underlying DNS query, the query type, the query name, and these things are generally accessible logs. It's not a detection canon. It is a authoritative source of truth that allows you to query against it and determine things like, what are the domain lookups that are important to me? Am I seeing domain lookups that are not attributed to a CDN that look funny? And then as a later stage, as I mentioned with some of the content packages, part of our C2 and core collection produces a DGA log. Our engineers here at Corelight and our researchers here at Corelight have gone through the paces, have understood the types of generators and flags that are common between DGA algorithms. And again, not producing an alert, just producing a log for a SOC analyst to go review. In this case, the customer was able to determine a valid C2 channel using a DGA domain via the DGA log, and something that was not alerted on by any of their other cloud native tools. Next slide. So we're focusing a bit on DNS, but I want to make the case that within our cloud infrastructures, there are a number of alternate channels folks can use. The space is ripe for attackers to leverage to do their ill will. In our public subnets or public-facing VPCs, it's typical that we have strict access controls, strict egress controls, because it's well understood what should be talking to the world. However, when you move into the internal subnets and their need to interact with cloud native services, that picture is much less understood. They're typically open to things that are either within the same cloud context or within the same account, or that are allowed by the service provider, and there aren't strict controls around that. In this case, we are looking at, again, exfil over DNS, but this could be one of many protocols that are native to the cloud. We see, and I've been a part of a number of red team exercises or purple team exercises in the past where simple ways of exporting traffic or exporting files is by appending them to a DNS name and leveraging that channel to get it out of the environment because it was an open channel. These same things are true in the cloud, right? That at that first point, DNS traffic is ubiquitous and noisy. We all know that to be the case. Building detections off of DNS traffic is extremely difficult, and it often fails when we move to a signature-based method. And even if we were using a signature-based method, custom field names or subdomain names that are reflective of my data going outbound are not going to be triggered by that signature-based detection. You can't easily turn it off for your internal or private subnets, or else cloud native tools break. And using external servers, again, does not typically trigger an alert. So what we see in the case of this customer is that given the DNS query and response values, and looking for large and randomized DNS requests, much like the DGA request, but instead of a single or multiple communications to a single domain name, multiple iterative domains with a positive value on the query and response side, this customer was able to decipher and discover data exfil by their red team to a command and control server that they had set up via DNS. Now, the command and control channel and the exfil of data over DNS were two separate objects, but it just shows the power of what's available in the Zeek logs and how the same log can be leveraged in a number of ways to build detections that are specific to the customer or specific to the environment. And again, given our content packages, we've gone a step further and built content that uses the underlying Zeek engine and the scripting engine that comes with it to build a specific log that identifies potential DNS tunnels. One of the caveats there is that we also are able to decipher any additional protocols that are running over those channels. A big red flag is HTTPS over DNS. I know of a few, but do not think it is the case for many that we are leveraging SSL or encrypted traffic over our DNS channels. Next slide. So this is one of my favorites. We talk about the overall composition of encrypted traffic in our current workflows. A large amount of the traffic is encrypted, but that does not mean that it is invisible. The problem being that it is nearly impossible to restrict access to what we call encrypted services, because without the content being visible, we cannot create controls that restrict access based on that content. So it's also common for internal services to leave things like SSH open for developers to do some level of debugging or troubleshooting, for break glass access to the underlying infrastructure. These things are it's just a reality of the way we've architected things in the cloud. For that reason, we have not built very good detective controls around things like SSH or SSL or HTTPS. And it often bypasses the firewalls and network threat detection tools. In this case, again, the Corelight content uses SSH inferences to show that files were being transferred over that channel. Now, I won't get into the nitty-gritty about how the SSH inferences work or how the encrypted inferences work. If you hit the Corelight page, there's a full white paper on our encrypted traffic insights. But using things like timing and overall transactional volume, we are able to determine whether connections have interactive sessions, whether they're interactive, whether they have files transiting over them, the types of authentication used, whether MFA is included. But this is a representation of that log being useful for this customer's identification of red team activity and the exfil of data over an encrypted channel. And no other tool fired an alert for this. No other tool even gave a hint that this was occurring. Next slide. So lastly, and this is something that is a North Star for folks, that behavioral detection piece. This is something that's very difficult to do. We've leaned on machine learning in ways to do this. We've learned on UEBA products. There's a high number of false positives. In my past lives as an operator and then as an implementer of tooling and technologies, tuning false positives for machine learning or AI-based alert tools is a pain. And not only that, there is a lack of awareness and context around signatures or routes to developing machine learning algorithms off of customized malware. We don't have those hashes when they're new. We don't know those C2 domains when they're new. So it's an interesting problem that needs to be resolved, given that in my past experience, all the malware that was deployed to our environment has been custom. It's also worth saying that a motivated attacker is going to find a way to get malware into your environment. That is just a fact, regardless of the types of controls we put in place, regardless of the types of access methodologies we use, regardless of the ways that we micro-segment services and systems. A motivated attacker is going to find a way to establish a foothold, deliver malware, and start communicating out, whether that be through an environment that is lateral to them or directly out to the internet. Our solution is that we've created C2 content that looks for and identifies C2 traffic. In this case, our customer was able to detect in the HTTP post body the payload that was dropped by the malware and was able to understand the communications within that malware control channel through, again, the HTTP post body. Now, we looked at the original slide that showed the correlation between the multiple logs within Zeek. There was the HTTP log, the DNS log, the con log, the files log. Those are all stitched together with a unique ID, which shows the correlation between all different log types and that original connection value. With that being said, it's possible to cross-reference across multiple logs using that connection ID string to see exactly what that HTTP post body represented from an originator address and then into the other UIDs to identify what other activity that specific host has taken or that malicious entity has taken. This level of inspection, this level of contextual awareness and contextual clues that are available in the data, again, looking at historical PCAP-based solutions or looking at signature-based solutions and the ability to cross-reference, it was prior never there. Next slide. So let's talk about the anatomy of a ideal cloud NDR stack. Some of this is theory, some of this is not yet fully operational. However, we've come a long way in meeting many of this criteria. The first of which is being able to automate and deploy these things at scale. Being able to manage your NDR stack as infrastructure as code or infrastructure as a service means that you can deploy and meet the needs of your detection and visibility story across multiple regions, wherever your data is. Ideally, and we are working on getting to this point here at Corelight, is that we don't need any taps or any agents. Currently, we're satisfying this through leveraging GCP's taps to feed the Corelight software sensors or virtual sensors. But in short order, we should be in a place in which none of that is needed. We hope to fully extract all L7 metadata from the raw traffic. That is the absolute necessity based on some of the things that Anton stated earlier, right? Flow logs are not comprehensive enough to give indication of what a skilled attacker is doing. They are not comprehensive enough to provide identification of an APT-like actor. Things like the HTTP referral field, things like URI use, things like the individual DNS queries and responses. Those things are required to create detections that meet the needs of our organizations. And those things are required above and beyond the identification that a connection happened in order to reduce false positives and to allow the SOC to mature and grow as they better understand cloud native workflows and as they better understand the interactions with their cloud services. Traffic collection from every machine is possible in the cloud because deploying taps in the cloud is easy. You know, in my previous life, in order to get a tap into the data center, I had to create a purchase order. I had to wait weeks. I had to get the thing to the data center. It sat on a truck for who knows how long until the data center engineers decided to pick it up and go install it. I had to go get that thing cabled up. I had to go, in some cases, retap the infrastructure to give me east-west visibility. I had to deal with overall port availability issues because, you know, once you move into the east-west space, a 48 port switch or tap aggregator will fill extremely quickly. So it was both resource and monetarily prohibitive to install visibility everywhere. That does not exist today in the cloud. You know, it is very easy to go tap every machine, go tap every container, and route that traffic to an NDR implementation that gives you that visibility everywhere. Unlike some of these cloud native platforms, and I won't harken back to my previous employer, but there are black boxes that exist there. We have no idea exactly what is being analyzed, what is the underlying principles or method for detection, how the alerts are generated. The lack of context is not something that we can tune within the cloud. And it's generally a black box alert cannon. I get what I get, and I have to figure out how to best triage that and hand it off to my SOC to become inundated with these alerts and then try and effectively do their jobs in the cloud. Lastly, you know, insights into encrypted traffic, as I spoke on earlier, these things are utterly amazing. Given the prevalence of encrypted workflows, to be able to now state definitively this is a machine-oriented connection versus this is a interactive-oriented session versus there are files transiting over this connection versus this is the MFA or authentication method used over this channel. These insights are extremely valuable in providing SOC operators with the tools and data that they need to definitively state this is supposed to be this way versus I don't know what's going on. We need to take a deeper look. I can now pivot to the host or pivot to additional log types to gain some more clarity, but it all starts directly on the network. And the last is, as Anton can attest to, things like GCP and Chronicle make this available at cloud scale, right? This data is generally available for everything within my infrastructure, for all of my cloud offerings. And that retention timeline, storage is not the cheapest thing in the world, but it's relatively cheap. And that means we can more or less keep things indefinitely. Anton, do you have any additional color for things here?
I would add things focused on the analytics scale and collection, because as we discussed, Layer 7 metadata is a lot more portable and in many cases a lot more useful than full pickups. But at in a large network, at the high bandwidth links, we're still talking about a sizable chunk of data, especially if you want to retain it. So while we can talk about how you want to collect the data, how you want to correlate it with other sources, enrich it, for many organizations, that's still kind of on the impractical side, especially if you want to retain for a year. So to me, I want to strike the point number 7, of course, the need for a cloud scale analytics platform like Chronicle. In our case, we take Zig data, we cross-reference it to endpoint data, to logs, and we retain it for a year for all clients. And again, we don't charge per gigabyte, which means if you are sort of floating in Zig data and EDR data and you want to A, have it come to life, and B, you want to keep it for a year to cover the typical detection timelines, Chronicle is a good answer because, again, if you have more Zig data, you're not paying more. To me, cloud scale here doesn't just mean doing things in the cloud. It really means doing things the way cloud native organizations would do it. And while usage-based pricing is common in the cloud, to me, volume-based pricing for security usage is just strange. So for Chronicle, for example, we built a per employee-based pricing model. So if you have more data, so what? You have more data. You probably need more data to analyze, look for more use cases, to hunt, to investigate. So to me, cloud scale platform, long retention, and lack of volume-based pricing are quite critical. And that's what I wanted to highlight here.
Excellent. So now let's take a look at an example of an NDR solution with a reference architecture. So in this case, we're seeing a deployment with both with the source and the destination in peered VPCs. And in this example, we have a centralized collector model. So this way you can have instances in different VPC networks. They're sending their mirrored traffic to a collector that's in a central VPC network. So, that way you only need the single destination collector. And, the benefit here is that you're, concentrating your security tools, in this case, Corelight sensors, into a single VPC, and that reduces the complexity of managing these tools across multiple projects, multiple VPCs. Then in turn, we have Corelight sending a couple of data sources out. So we have extracted files that are being sent to a file analysis tool, in this case, VirusTotal, and then we have the Zeek logs, Suricata alerts, sending those out to a SaaS-based SIM like Chronicle. And then on the right-hand side, you can see a list of the Corelight logs that are supported by the Chronicle UDM. And with that, I'll hand it back to Bernard and Anton to close out the presentation.
Perfect. One thing I wanted to highlight as we're starting this type of wrap up is that even though for many organizations, they sort of think in EDR, they think endpoint, they think, hey, let's catch them where the attackers are. What I want to highlight is that the 3-pillar model of the triangle of detection, triangle of visibility that I highlighted back in my Gartner days still matters a lot. So even though you may like EDR, doesn't mean you should obsess about EDR and just go there and then ignore everything else. So to me, in today's kind of endpoint skewed world, NDR still matters a lot. And that's a pillar of visibility that I expect to play a bigger role until eventually things would taper off when everybody becomes cloud native. I expect my children to retire by the time everybody is just purely cloud native. So I don't think that it's coming anytime soon. So to me, this is kind of where the longer term future may, in theory, point away from network-based detection. For the foreseeable future, it will be quite valuable alongside other approaches. So another point I wanted to highlight is that as you focus on your cloud migration, the digital transformation efforts to move into the cloud, you would have NDR for on-prem use cases, you would have NDR for cloud use cases, and frankly, I expect that using the same tool set is the right approach. So, for example, in this case, Corelight plus Chronicle would cover you in Google Cloud, it would cover you in other clouds, it would cover you on-prem. So you would get some of the cloud benefits from Chronicle backends, and you would get coverage for on-premise and the clouds. So to me, this type of smooth transition is how I want to architect things. Now, point number 3 is just a pure kind of like a marketing salesy point about Chronicle, because when we talk cloud scale, it isn't just about can it work? Well, yeah, it can work. That's not the point. The point is that can it work and not break your budget? To me, that's quite a bit more central compared to can it work, because frankly, anybody who builds a tool using modern approaches, who is somewhat intelligent and builds a tool that backends to any of the cloud providers, can make the tool that works. That's not exactly a challenge. The challenge is the tool that works for actual clients for where they are and where their budgets are. To me, with Chronicle, you can achieve cloud scale not just in terms of a cloud native tool set and working at cloud speed, Google speed searches, but you're also getting a flat pricing model. To me, that's quite critical, because to scale with the cloud, you expect your capabilities to scale, but you don't expect your budget to scale. So to me, I'll just keep hitting this point whenever people ask me a question about this. So I get a bit tiresome a little bit. But to me, cloud value isn't like, oh, we have APIs. Cloud value is you get more capability, you get cloud speed, but you don't get to pay on-prem prices. You get to pay much less.
Yeah, and I'd like to highlight that the core value for me is my comprehensive understanding of risk. Right, as new risks emerge, as new threats emerge, as I become aware of risk evident in my infrastructure for whatever reason, whether because a pen test showed me these things, whether it's because a zero-day vulnerability came out, how do I know that I'm covered? And even more so, how do I know that my controls are working? It all ties back to the network transactions that are on the network. And Zeke being able to show me exactly the types of connections that are going on, the exact types of sessions, the encrypted insights, and what's going on with my controls is a requirement for me. And then lastly, I made the point earlier that these things meet you where you're at. That with this now being a data problem, it goes from I need very specific tool sets and skill sets to go analyze PCAP to I can stick my junior analyst in front of a Chronicle dashboard and say, go evaluate connections, or I can stick my very advanced operators in front of a Chronicle dashboard or the Zeek data itself and say, go build me something that will give me some level of context around this specific exploit that's coming from APT2 or from Wizard Spider. And depending upon maturity, they can use that data in whichever way they feel is best to produce an outcome, that you don't have to change the underlying tool, that you don't have to change the underlying data. And one of the last points that I missed earlier in the presentation is this is ripe for feature engineering. For those who are actually looking at building their own ML or AI workflows, there is no better place to start than a well-described schema for the network that's already summarized in a way that you can directly port into features that are relevant for your AI or ML applications.
Excellent. All right, so we are reaching the end of our session today, and we're about to open up the Q&A part of the presentation. So if you have any questions, feel free to enter those into the questions window. And here's our contact information as well. If you would like to get in contact with us or read blog posts, Anton's got some great posts up on his Medium account. And with that, just a quick note on some resources. We'll make these slides and these links available to you. Some good resources if you'd like to learn more about Corelight and Chronicle's solutions for network detection and response. So we'll go ahead and open up the Q&A session. First question that we have is, I'm new to NDR. How do you recommend I get started? What's the low-hanging fruit I can tackle quickly? Bernard, would you like to take that one?
Yeah, I can take that one, and Anton, feel free to jump in at any time. But the low-hanging fruit for me is, where are you having issues with your current detection strategy and detection implementation? If you're new to NDR and you're being inundated with alerts from either the file logs or some other log type, or from a signature-based detection engine, how do you add the context that's necessary to drive down that false positive rate or to gain a comprehensive understanding of what all these alerts mean? I would take the areas that you are spending a lot of time in the SOC churning cycles on, and then look for an opportunity within that NDR data to shut that down. Essentially saying, if I had this field in the HTTP log, like the HTTP refer or the HTTP status code, that could help me validate these false positives and move this bulk of alerts off my plate, leverage NDR in that way.
Excellent. Next question. How does Zeek compare to NetFlow?
This one is not gonna die. This question just comes up from people for as long as you existed, right? So I'm sure you have a good answer, but I want to add something after you answer.
NetFlow is, single direction oriented connection flow logs, right? You're only given a small subset of information about what happens. That's usually source dest and then overall source dest port and then overall bytes transferred in either direction. It's extremely difficult to stitch together entire sessions. It's extremely difficult to understand what happened in those sessions. Zeek is the difference between, somebody taking a picture at one point in time at a concert and trying to describe to you what songs were playing, and having a full YouTube video of that same concert that you can go pick up, rewind, zoom in on, and otherwise, right? You have full contextual representation and full summarization of everything you care about that transited in that connection. Anton?
Yeah, I would say that the main challenge with trying to detect anything modern with just using layer 3, using source destination port protocol, is that pretty much almost everything application focused is going to have to be guessed at, or you would miss it. I mean, if you look at pretty much many indicators that mention referrals and parts of the URL and other stuff, it's all lost in NetFlow. So to me, pretty much anything application level that shows up in indicators and thread descriptions and reports and just general knowledge, it's not there. So while I've seen some pretty creative applications of NetFlow, I just don't see how a lot of modern threat landscape can be can be caught with just layer 3. I mean, whenever I say this, people show up out of the woodwork and say, here's an example. And I agree, there are examples. You can always point out traffic spikes or scans and other things from the 1990s, but it is 2020s. And a lot of attackers' activities have to be seen in layer 7, not in layer 3. So to me, that's why I usually highlight the value of Zeek metadata over NetFlow.
Excellent. It looks like we have one last question. How is Corelight different from the open source Zeek project? Bernard, that's probably a good one for you to take.
Yeah, if any of you have ever attempted to roll your own Zeek, I think you can understand the value in having an enterprise level provider for that service, right? That you no longer have to manage or maintain the underlying broker processes. You don't have to worry about CPU overhead. You don't have to worry about optimizing the NIC to gain, if you got a 10 gig NIC card, at my best efforts, I was able to get about 4 or 5 gigabits of traffic inspection. Those are challenges that you no longer have to face. So the first of those things is that Corelight is the easy button for managing and deploying open source Zeek, and that we package things in a way that allow you to gain full optimization of the underlying engine. Our 10 gig sensors give you 10 gigs. We have 100 gig sensors available in 1 RU. The second piece of this is that we have stitched in some of these more formal areas of network detection and of PCAP. We've got products out today that include Suricata and that include Smart PCAP. That if you do require PCAP for some reason, you can create policy that says if Suricata alert fires, or if this is visible in some log field, please capture PCAP and store it to disk. But aside from that, do not store PCAP in mass. And then the last of which is the content that you get with Corelight, right? I've mentioned the C2 collection. I've mentioned the Encrypted Insights collection. I've mentioned the Core Insights collection. Now, you have the full freedom and flexibility to mess with the underlying Zeek scripting engine or with the Spicy protocol analyzer and roll your own custom log types and custom detection types. That's all available to you. But to get those things as a package within the same box from day one out of Corelight, I think that puts you in a place that accelerates your ability to discover decipher and then disrupt activities by malicious actors, whether those be your script kiddies all the way up to your advanced nation state actors. Anton, do you have anything there?
No, this one is pretty, yeah, I don't want to engage in this. This is a better question for you. I mean, I've seen happy open source Zeek users, of course, and I don't want to say anything even remotely bad about this. People have made it work well. And but I would say in my experience, admittedly in real operational environments, I have somewhat limited experience with this, as the scale is what drove people to Corelight over Zeek, is that this like having to scale up, having to have stuff perform adequately is way harder than many organizations can handle. And performance engineering is a separate art. Some would say it's a kind of a black art. And getting open source to perform in this case is the toughest challenge I've encountered for this. I mean, it works, but does it perform? Is what I'm pointing at.
Excellent. All right. Well, thank you, Bernard, and thank you, Anton, for joining us and presenting today. We'll now hand it back to Carol to close this out.
All right. Well, thank you so much, Edward, Bernard, and Anton, for your great presentation, and to Google Cloud and Corelight for sponsoring this webcast, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.